Okay, let's get started. What have we got here? MSSL sequence of series paper 1. Hydraulic hammer drives the metal post vertically into the ground by striking the top of the post. Distance at the post is driven into the ground by the nth strike. Let's go for blue. Is dn. Distances d1, d2, d3 form a geometric sequence, so that's quite nice. It's telling us that it's geometric. Distance at the post is driven into the ground on the first strike of the hammer. D1 is 64. That's going to be handy. Let's write that down again. D1 is 64. Distance post driven to the ground on the second strike. D2 is 48. D2 is 48. So the start of our sequence effectively is 64, 48, and what we're looking for is the common ratio. Now, remember, it's how we get from 64 to 48. What do we times by to get from 64 to 48? Now, to work it out, we're going to do 48 over 64, which when you plug it into your calculator, it's going to simplify nicely to 3/4. So that's our common ratio. We're timing by 3/4 here, and so R is equal to 3/4. Okay, part B. Find the distance that the post is driven down by the 8th strike of the hammer. So we're looking for the D8 effectively, and we're probably going to reach for our formula booklet here, and it's going to tell us that it's U1 times by R to the power of n minus 1. And all we're going to do is plug in all of our values. So for D8 specifically, U1 is what we had previously, that was 64. Times by my common ratio I've just worked out, 3/4, now to the power of 8 minus 1, or 7. So we're going to plug that into our calculator, and we should get a value of 8.54 centimetres. Okay, part C, find the total depth. Total is a big clue for us. Total means we're going to now be dealing with in the series, so it's going to be the sum of all the sequences after the 10 strikes of the hammer. So again, reach for the formula Booklet. Sn equals U1 R to the n minus 1 over R minus 1. And that's just the first one of the two options. You may have chosen the other one. U1, therefore, is going to be 64 again. The common ratio is 3/4. Now that's to the power of n, which is now this time 10. Take away 1, and we're going to divide that by 3/4 minus 1. And you can tidy it up along the way to include more workings, but you should get a value of 241.58 centimetres coming out.